Now, let us learn something about virtual circuit approach, which is connection oriented service, which is not same as datagram approach, which is connectionless service. In datagram approach, the packets of the same message were sent in different routes to reach the destination, and they were not dependent on each other. Whereas in case of a virtual circuit approach, there is a relationship between all packets belonging to a message. Before all the datagrams in a message can be sent, a virtual connection should be set up to define the path for the datagrams. And after the connection is set up, all the datagrams follow the same path towards the destination. In this type of service, not only must the packet contain the source and destination addresses, but they should also contain a flow label, a virtual circuit identifier that defines the virtual path the packet should follow to reach the destination. So this is how the virtual circuit packet switched network will be there, where when before the packets 1, 2, 3, 4 are being communicated, there is a virtual circuit being established. So this among the paths, for example, R1, R5, R4 destination, R1, R3, R4 destination, R1, R2, R4 destination, or otherwise R1, R3, R5, R2, R4 destination. Before going to all these, even R1, R2, R5, R1, R3, R5, R4 destination, like that there are several routes. Among all these, the best route is selected based on some routing algorithm, and it is decided to be, if it is decided to be R1, R3, R4 and destination, then a virtual circuit is being established, and after establishing that virtual circuit, all the packets flow in the same order towards the destination. As 1, 2, 3, 4, it flows from R1 to R3, R3 to R4 and R4 to destination, and this is called virtual circuit packet switch network. So how is this virtual circuit being created? So here, how does the forwarding process happen in a router when using a virtual circuit network? So the data packet will not contain only the destination address, but it will also contain the source address, and this network layer will add an label to it. So this label is going to be the virtual circuit label, and that is L1 here, the incoming label, and the forwarding table is also going to be of different type. It will not contain only the interface number, but it will also contain consider the labeling. So the datagram packet is modified with the header, and the label is being changed. So based on the label, the port, the incoming port, if it comes from incoming port 1, and if its incoming label is L1, then it has to be sent through port 2, and the label should be L2, because the same interface can act as virtual path for more than one message also. So which is the corresponding virtual circuit, that label is being given here. So through this L1 it flows, and the label alone is decapsulated and then encapsulated with the new label, outgoing label, as L2, and this is the forwarding process happens in the router in a virtual circuit network. And initially, how the virtual circuit is established? So it is established with the help of a request packet. So how it is being sent? So the request packet is going to be, for example, it is going to contain like A to B. A request packet is sent from the source to the destination, and this auxiliary packet carries the source and destination addresses alone. So when it is being sent from the source, the source A sends a request packet to R1. The R1 receives the packet, and it knows that a packet going from A to B goes out through port 3. How the router has obtained this information is a point to be covered later. So for this moment, assume that it knows the output port. The router creates an entry in its table for this virtual circuit, but it is only able to fill 3 of the 4 columns, like it is coming from through port 1 and label is something that is 14, and it is going out through port 3 and it is not providing any label as of now for that. Okay, so it only fills the 3 of the 4 columns. The router assigns the incoming port and choosing an available incoming label. What is there in the packet, that label is taken and the outgoing port is assigned. It does not know the outgoing label, which will be found during the acknowledgement step. The router then forwards the packet to port 3, so it reaches the router 3. Router 3 receives the packet and that is setup request packet, and the same event happens in route similar to R1. So it fills, it takes up that incoming label 66 and it is going to fill that, and it is going to now it is going to leave that 4th column empty and it is going to send it to R4, and this process continues until it reaches the destination, and the destination B receives the setup packet, and if it is ready to receive the packets from A, it assigns a label to the incoming packet that comes from A. In this case it is going to be, let us see about the acknowledgement. So after the request packet reaches the destination, the virtual circuit is established. Now the acknowledgement packet is created, and the acknowledgement packet is a special packet called the acknowledgement packet. It completes the entries in the switching table. So here in this case it is 77, which is the label, and this label lets the destination knows that the packets coming from A and not from other sources. So now it sends back, B sends back to the router the acknowledgement packet. So when it is being sent to R4, the acknowledgement carries the global source and the destination addresses, so the router knows which entry in the table is to be completed. So the packet also carries label 77 chosen by the destination as the incoming label from the packets for the packets from A. So that 77 is being placed. So the router R4 uses this label to complete the outgoing label column for this entry. Now 77 is the incoming label for the destination B, but the outgoing label for router R4. So R4 sends the acknowledgement to R3. R3 contains the incoming label. So when it has to, R3 uses this as the outgoing label in the table. So this process continues until it reaches the source. Finally, router R1 sends an acknowledgement to the source A that contains its incoming label in the table chosen in the setup phase. So now the source uses this as the outgoing label for the data packets to be sent to destination B. So this is called as establishment of virtual circuit. And how does the data transfer take place? So after all these tables are filled up with the port numbers and the corresponding labels, the data transmission is normal. When the packet is being sent, the source and the destination addresses are added in the header part, and the label is being the label of the incoming label of the sender. Then when the incoming label is this one, it means that it is coming from A to B, so it will be forwarded to outgoing label. It is forwarded with outgoing label 66. to router 3, that is port through port 3. So this process continues. 66 is replaced by 22 here, 22 is replaced by 77 here, goes through ports 4, and finally when B receives, it knows that when it is 77, it is intended for itself from A through this virtual network, okay, and the source and the destination address will be inside A and B. So it will decapsulate that packet and then open it and then further process it. So this is how the communication happens in a virtual circuit. And there is teardown phase, where a source A, after sending all the packets to B, sends a special packet called teardown packet. Destination B responds with a confirmation packet. All routers delete the corresponding entries in their table. So that phase is also important. Okay, thank you. Let us see about the network layer performances in the next class.